I want to teach you how to solve differential equations using method of separation of variables. So our equation is partial u partial x is equal to 4 partial u partial y, and our initial condition is u 0y is equal to 8 exponential of negative 3y. Okay, so we have to define our function u. Our function u is equal to x and y. So it has two variables, okay, and x is an independent variable and y is an independent variable. So the next thing we have to do is to insert back our function u back into our initial equation. So partial u partial x is going to be x prime. We are differentiating x, but we are maintaining y as a constant, okay, is equal to 4 partial u partial y is going to be x y prime. We are differentiating y but maintaining x as a constant, okay. So we want to collect like terms. So this is going to be x prime over x is equal to 4 y prime over y, okay. And we are going to equate this one to a constant k, because this one is an independent variable now, and y prime over y is an independent variable also. So we can separate these variables now. We can have x prime over x is equal to a constant k, and 4 y prime over y is equal to a constant k, okay. So we are going to integrate both sides with respect to the independent variables. Like the first part, we are going to integrate with respect to x. So when you integrate this function here with respect to x, we are going to have the integration of 1 over x is ln x, okay, and this one is equal to, when you integrate k, we're going to have the constant k with x, okay. When you integrate a constant, you're going to have a k with an x, because you're integrating with respect to x, and you're going to have plus another constant c1, okay. And this one, really the solution is going to be, our x is going to be c1 exponential kx, okay. That is the solution of this, of the first equation, okay. For the second equation, where we have a y, we are going to have 4 y prime over y is equal to k, okay. And really we can have y prime over y is equal to k over 4. This is just to get the like terms together, because the 4 is a constant and it is going to go to the other side of the equal sign, and you have to have k over 4, okay. And when you follow the same procedure we had for x, we are going to say this is ln y, okay. The natural log of y is equal to k over 4, okay. When you integrate a constant, we are going to introduce the independent variable y, okay, plus a constant. We are going to name this other constant c2, okay. And this is now is going to be y is equal to c2 exponential ky, okay. But when we go back to our function was u is equal to x, y. Now this is a product of x and y, and we have two values here. Y is equal to c2 exponential ky, and x is equal to c1 exponential kx. So we are going to multiply these two equations. So our u is going to be x times y, which is c1 times c2 exponential, okay, kx times ky, okay. Because they are exponentials, we're going to add them. So we are going to have kx plus ky, okay. So we are going to, this is a function u, and you're going to equate it to our initial condition, 8 exponential negative 3y. So 8 exponential negative 3y is going to be equal to this other side of the equation, okay. But at this initial condition, we realize that our x is 0. So we are going to substitute that x 0 in our equation here. So when you substitute x is equal to 0 here, we are going to have c1 and c2 are constant, so we can give it another constant, maybe a. So that is the exponential. X is 0, we are going to have ky is equal to 8 exponential negative 3y. Okay, and so from this equation you can realize that our constant a is just equal to 8. Okay, plus we had another 4 here, we had another k over 4, so we just have to include the k over 4 here, just have to include our k over 4 here. Okay, and this implies that k over 4 is equal to negative 3. Okay, and this implies that our k is equal to negative 12. Okay, so if our k is equal to negative 12, we are going to substitute back our solutions back to our equation, which is u is equal to c1 c2 exponential kx plus k over 4y. Okay, and now our solution is going to be u is equal to c1 c2 is a constant 8. Okay, exponential k is negative 12, so you have negative 12x plus k is negative 12. Okay, so this is negative 12 over 4, that is negative 3y. Okay, and this is 8 exponential negative 12x minus 3y. Okay, and this is our answer.